Welcome to the video on the electron flow versus conventional flow. We all heard about Benjamin Franklin flying his kite in a lightning storm. What he made a mistake on is he was looking at the lightning. The lightning he thought was electrons flowing, which in turn turned out to be photons. So the whole conventional flow in electronics and electricity is all based on this theory. All of electronics is based on conventional flow when we look at the symbols. The arrow flows and points to the lower potential or ground. So these are all based on conventional flow. What happened later is that physicists in the lab found that electrons actually flow from the minus terminal into the plus terminal. This direction is called electron flow. Technicians use electron flow and engineers use conventional flow. Doing calculation doesn't matter as long as you're consistent. Here I'm showing Kirchhoff's law series circuit and utilizing conventional flow, where we flow from the positive terminal through two resistors back to the battery. So one thing about series circuits is that the current is the same no matter where we measure it in the circuit. And the current coming out of the battery is equivalent to the current going back. We can't lose that current. Also, voltage is shared among the users, the resistors. So when we add the voltages of all of our resistors, they're going to equal to the voltage of the battery. Here's a diagram showing Kirchhoff's laws based on a parallel circuit. And this is also conventional. And we have three resistors in parallel. The voltage of each of these resistors is going to be the same. So the voltage is consistent. And what happens is we have current coming out of the battery is equivalent to current going back in the battery. And each of these branches, the current in each one of these branches, will add up to the current in the main. And that's the conventional theory of Kirchhoff's laws for parallel circuits.